Good evening, everyone. Welcome to day 4 of online ATAL FDP program on optimizing next gen computing for smart system development. Today, session 7 and session 8 will be taken by Dr. Dinesh sir, and the topics will be optimization methods in deep learning and its application on smart system deployment. And the other session will be optimization methods in generative AI and its industrial applications. So, let me introduce sir to you. Dr. Dinesh is a managing director and head of business at Samsung Electro-Mechanics Bangalore. Prior to joining in Samsung, he worked for companies like Amazon, Honeywell, HCL Technologies. He was a postdoctoral fellow at Seoul National University. His areas of research interest include image processing, pattern recognition, computer vision, and machine learning. He has over 75 publications to his credit at both international and national journals and conferences. He also has 27 awarded patents to his credit. He is serving in the editorial board of several journals. He has been identified as reviewer for several international journals and conferences. He has served as program committee member for several national international conferences. Sir has successfully guided 6 PhD scholars and presently guiding 3 PhD scholars. He has successfully guided many academic and research projects. He is a life member of IEEE, Computer Society of India, and Society of Statistics, Compute and Applications, International Association of Engineers, Hong Kong. He is also serving as member of Board of Studies, Board of Examiners, and Advisory Committee in several universities. We welcome you, sir.
Thank you. Thank you, Mani. Thank you for the introduction. So, good evening, all. Welcome to this session. And before I start, let me take this opportunity to thank organizers for giving me the opportunity to share my views and experience. So, basically, as the topic mentioned, I'll be talking about some of the optimization technique. Before that optimization, like we saw how to build the model, AI models, and from the edge AI perspective, how to put these models onto like so the different infrastructure. Like, so probably like building AI model is one aspect, but how are we going to optimize these models to put it into like the edge devices or like so the low cost infrastructure is what the topic of today's discussion. Nevertheless, like okay, so I will try to start from the basic. And if you have any questions, you can always feel free to stop me at any point of time. And at the same time, if the topic is like was already covered, like so, let us try to skip. Okay. So that is the pretext, and let me share the screen. So are you able to see the screen?
No, sir.
Just a minute. Just give me a minute. Are you able to see the screen now?
Yes, sir.
Okay. Yeah. So typically, like this is the topic. Mainly, like we will be touching upon the aspect of deep learning, mainly from the point of image and video processing applications. So these are the applications we will try to look into it, and mainly the point what we will be focusing is how to optimize the CI models, right? So okay. So this will be the agenda I'll be talking about. So first, we'll start with the background of neural networks. I think most of you are familiar with the neural networks. If it is not familiar, like we will let us briefly touch about the concepts of neural networks, and then like so we'll try to see how this concept of deep learning was linked to the neural networks. How like so the deep learning models are built with the help of from the concept of neural networks, and we will also try to understand very some of the fundamental questions in the area of see, today we are talking about all the advanced terms of the AI, right? So we are talking about generative AI, language models, and then like so we are talking now we are talking about agents and agentic AI workflows. But before that, like so, what is that one technique? So which transformed this entire domain of machine learning or the artificial intelligence is with the advancement of deep learning. So let us try to spend some time to understand why deep learning. Okay, what was the limitation or the challenges with respect to like with the shallow learning, and then probably we'll try to address this. And this is where I think probably it gives like a lot of insight how deep learning enabled like so the rapid growth or the rapid expansion of the technology in the area of artificial intelligence what we see today. Okay. And probably like okay, so when we talk about the images. So CNN plays a vital role. So including your vision transformers or like so image captioning and like so today image search, whatever the technique you try to use, right? So all these things require the concept of convolution neural network. We'll try to understand like what is CNN, and we will also look into like few of the industrial application where like so which different industries and academia is working towards this kind of application. So this could be having some relevance to your current PhD problems. We will try to discuss about few application, and then we will talk about the generative AI, and then like also the optimization technique. So this is the topic. As I mentioned, though this is the topic I'm planning to cover. So if you need any specific topic or like some more interest, like more information on any particular aspect, feel free to stop me at any point of time. We'll discuss and we'll try to. And I want this session to be more interactive so that I can, rather than like so only talking about some of the concept what I have captured. So utilize this time to pose or the raise the questions so that I think probably I can give like so different insight from the both from the industry as well as from the research standpoint, right? So without wasting much time, let us see like let us try to start with what is artificial intelligence. I think everybody is talking about artificial intelligence, right? How do you define artificial intelligence? What exactly like what is artificial intelligence is?
Imitate human beings.
Yeah,
To imitate human beings.
imitating the human being. Why at all somebody has to imitate the human beings?
To make decisions, sir.
Hmm?
To make decisions.
To make decisions. So humans as a humans we are good at making decisions, right? Why at all we need to imitate that?
For perfect decisions, sir.
All we work as we do. We
Do
need
you
to
think
be
AI make a perfect decision or the perfect decision than humans?
It's based on condition where human cannot deal that data sets, sir. Large amount of data sets are there, so
Yeah,
human cannot predict that whatever the decision they want to take.
right. Typically like okay so the humans as a humans are like okay, so until now like okay, so we are most smart and intelligent animal on the universe, no doubt in that. And so we are good at making a decision. We can make a decision based on like so the componenting data, and we can change the decision or we can optimize the decision according to the situation. But there is one problem. So I can make a decision only when I have like so the supporting data. See, for example, if you have like so only two routes. See, for example, you want to travel from point A to point B. There are only possible two routes available to reach from point A to point B. then you can make a decision like so which route is good in what time, depending on like so the condition of the road, or it could be based on the congestion at any point of time. So based on that, you can make a decision. On the other hand, assume that there are 1,000 possible ways to reach point A to point B, and there are various parameters. Like it could be the weather conditions, it could be like the condition of the road, it could be the density of the vehicles on the road, like that. Like so, if there are multiple parameters, probably humans still can make a decision, but he may take longer time to analyze and make a decision, because unless I know the actual condition of all the parameters, right, probably like my decision won't be like okay, so the optimal. Okay, to make an optimal decision, the accurate decision, we need to comprehend with all these kind of data. But comprehending all this data, as the number of options or number of choices are more, probably it take more time. Okay, that's where artificial intelligence system can beat humans, right? Okay, so that's what like so that typically like I think all definitions are more appropriate, more or less. So typically, artificial intelligence, as the name itself says, right? So as a humans, we are most intelligent animal. We proclaim ourselves as the most intelligent animal. So basically, like we want to imitate this kind of intelligence with the help of computers. Okay, that's why like so we are trying to give that kind of intelligence for the algorithms, so that these algorithms can mimic or exhibit the intelligence. Then how these artificial intelligence algorithms are like so what is this artificial intelligence then? Artificial intelligence is nothing more than a set of algorithms, right? So which we are keep on writing like so since the day computers are invented or the programming languages are invented, so we are keep on writing the programs. We are writing the programs to perform the task. And again, those performing tasks are nothing but algorithms. And again, your artificial intelligence system, or like so the artificial intelligence system purview or the framework, whatever you say, it is a collection of algorithms. What is the difference between like so the traditional algorithm and the artificial intelligence or AI algorithms? The main difference is, in case of a traditional algorithms, the behavior, what is the behavior exhibited by the traditional algorithm or the program? It takes some input, so like data from the external world. You key in some input. There is algorithm or the instance of the algorithm is or the program is running. It takes the input, process the input, and produces the output. That's it. So if you look into this entire AI system, that also performs the same task. It takes the input. There is a AI agent of the AI algorithm. It performs the task and produces the output. But what differentiates AI algorithms from the traditional algorithms? That probably we need to understand. All of you are able to get me right. Even if you're like, for example, if I take a very simple algorithm of sorting, what the sorting algorithm does? All of you are familiar with sorting algorithm?
Yes, sir.
Okay, what is the sorting algorithm does?
Compare two numbers and then find which one is the either minimum or maximum like that.
See, basically, it takes a integer array. Okay, so basically, take a list,
Yes, sir.
which is a input, which may or may not be sorted. Okay, random list, and what will be the output?
Sorted list.
Again, a list which is in a sorted list, right?
Yes.
So this is a input. If I put it in a very rough term, this is a input. This is nothing but a program, and this is my output. Now, this AI system also performing the same thing, and this traditional sorting algorithm is also performing the same task. What makes them difference? We don't call that sorting algorithm as intelligent algorithm. Do you?
No,
Yes
sir.
or no? You don't
No,
call
sir.
sorting algorithm as an intelligent algorithm, right?
Yes.
It's a collection of instruction. However, like the person who has written that sorting algorithm He's intelligent, like he knows in what sequence it has to be done. So like he has instructed the computer to execute this sequence in order to produce this kind of output. The algorithm is said to be intelligent only when the behavior. See, for example, I have written a sorting algorithm today. It is working fine. Even after 100 years, if I execute this program, what will be the output? What will be the behavior of the sorting algorithm? It performs only sorting. Yes or no? So it
Yes.
doesn't perform it. So that means its behavior won't change, even if I execute 100 times, 1,000 times, or millions of times. Okay, unless I go and modify the states inside this algorithm. Okay, so algorithm behavior won't change. Hence, these kind of algorithms are called traditional algorithms, where it is able to perform the task much faster than the humans do, but they don't exhibit any intelligence. Why? Because their performance is not expected to change over a period of time. On the other hand, let us see, like, okay, so as a humans, how we try to perform. So, for example, most of you are faculty members, right? Can I safely assume that?
Yes, sir. Yes, sir.
Okay, either you are a student or a faculty member. Okay,
Faculty.
now, yeah, you joined a particular organization, a college, and you are very new to this college. Today only you joined this college, or like you are joining this college. Like, so your home is at some location, let us say point A, and your college is in point B. You are new to this city. You want to go from A to B. That means from your home to college. How do you do? What is the step you try to do?
I will see the
What
short
you're
route.
getting like, hmm?
I will search for the
you
short route.
you search for the short route
Yeah.
on the day first itself.
No, no, no. I will search for the Google, the way
You
we.
use the
Yes, yes,
Google Map.
yes.
Okay. Assume that okay, Google Map is not there. Then what you will do?
I will ask here and there, and I will want to go. Is it you know?
You will ask here and there, and you will try to find. Okay, so what is the route from A to
Yeah.
B?
Yes.
Right? Correct.
Yes, yes.
If the Google Map is there, you will try to take the assistance of Google Map. If the Google Map is not present, then what you will try to do? You will ask the people, okay, how I need to go, like, so what is the mode of transport, and based on that, you try to move from A to B on the day one, right? So day two, probably you will take the same route. Probably now you are not going to ask the people now because already you are familiar with that route, like, so you will try to follow the same. Assume that, like, so you already spent 1 year. You are 1 year into that service in that college. Are you following the same route?
No, sir.
Will you follow the same route?
No,
Why,
sir.
why 1 year,
Why?
sir? It is there within 1 week. We can search for other route.
Within 1 week. Okay. So because I specifically chosen that 1 year, I will tell you, like, okay, so what is the reason for that 1 year in the next slide. But okay, within 1 week, so you will probably, like, okay, so you will try to find what are the alternate route, what are the possible other routes, and based on that, like, so you are trying to take a different routes. Agree?
Yes.
Yes.
Okay. What was the problem? Is the problem statement changed? Did I change the problem statement? No, right? So
No, no.
problem statement is still same. I need to move commute from point A to point B. That's my problem. On the day one, that was the problem. On after 1 week, that was the problem. That is the problem. After 1 year, the problem statement is same. What is the problem statement? I need to commute from point A to point B. Again, now, what are the parameters you consider to take a different route?
Distance,
One is distance.
safety,
Okay, you will try to take okay distance. Then
Traffic.
safety.
safety of the road, traffic.
Traffic.
So many parameters, right? See, probably like, okay, so if you are in a hurry, so you want to reach fast, morning, like you got up late and you are rushing, so then you will select the route which is shortest. While coming back from the college to home, so it's already late, it's dark, so then probably you will take the route which is safest. And like so, yeah, in between, like so if you want to shop something, you want to pick some item, then probably you will try to take another route, etc. and so forth. That means the problem is same, but depending on the situation, as the time progresses, the solution you exhibited to reach point A to point B are different, right? So that means you are evolving over a period of time, and your behavior is changing as the time progresses. As you gain the experience about the problem domain, as you gain the experience over the environment, your decisions or your solution options or the path for the solution is changing, right? So typically, if you talk about the conventional or the traditional algorithms, those kind of behavioral change you are not expecting. So even after 100 years, if I execute a sorting algorithm, it will perform the same task. Even if you execute on the supercomputer, it will try to perform the same set of steps. Step 1, step 2, step 3, step 4, etc. So you don't even care about like, so what is your input data, whether input data is already sorted or not sorted, nothing. It will try to blindly follow the steps A to N, 1 to N. On the other hand, so the intelligent algorithms are like the algorithms whose behavior is expected to change or its behavior changes over a period of time. Then we call such algorithms as a or intelligent algorithms. Clear? So that is the only difference. Otherwise, your whatever the program you are writing 50, 60 years ago, and whatever the program you are writing for, like so even today, it's same. Like so, it's a probably that time you was writing in basic or some programming language. The programming language is different. Probably like apart from that, for a machine, for a computer, even today, this intelligent algorithm and your sorting algorithm, it doesn't make any difference. It is a set of instructions. But how these instructions are being used is what makes the like so the intelligent algorithm. Clear? Right. So typically, as just like a humans, even the artificial intelligence algorithm takes the input. How does the human get the inputs? Do we
Through
get the input from outside?
through
Yes or no?
experience. Yes, sir.
Experience is not an input. Experience is what you have learned actually. What is the input? From where you will get the input?
Brain.
Brain. Brain is basically processing, right? How does the brain is where like so your most of the processing happens. How does the brain get the input from? Where does the brain get the input?
Not
Environment.
Huh?
situation.
Environment, sir.
So environment is outside. So typically okay. So this is
Situation,
your
sir.
brain.
Situation.
This is your brain. This is the environment. You want to make a decision. How do you how do you get the situation about the environment?
Sensory organs.
Through the sensory organs, right? Humans has a 5 sensory organs. Based on that, either you will try to see, listen, or taste, smell, and touch and feel that, right? So based on that, you will try to get the sense about the environment, right? So similarly, like okay, so we try to get the input from either from the eyes, nose, skin, okay, like that. Like so, with 5 sensory organs, we get the input. So it's just like okay, so the artificial intelligence system can also get the input from multiple sources. Either the data can come, the input could be in the data format, which could be like okay, so the tabular data. So input may be coming from the sensors like vibration, temperature, etc., and so forth. And input can be given from the images or videos in the form of images and videos. And all this input will be taken. Artificial intelligence system will try to process this data and try to produce us the output in terms of action. Okay, action means like so basically it will try to perform certain action if it is a agent. It will like okay if it is a, if you are building the algorithm for the robots, it will try to perform the movement of the robot. And if you are asking, like we say, your chat GPT, like we say, output will be in the form of a text, right? So input can have a multimodality, and so like your output can also have multiple modalities. Okay. So this is where the processing happens. Then what is this intelligent system? What are the intelligent tasks it can perform? Can it perform all kind of tasks, or can it perform the specific kind of task? That's where we need to understand. So now you are able to understand the difference between the traditional algorithm and the intelligent algorithms, right?
Yes, sir. Yes, sir.
Okay. So, so if you are a teachers, right? Most of your all of your faculty members in your classroom, if I ask a question, who is intelligent, who is more intelligent, who is less intelligent, can you rank them? You always tell that this guy is very smart. So some guys like, okay, so he's hardworking, but he's not very smart. What makes them like, okay, so what makes you, what are the parameters, or what are the criteria you will consider to group them or categorize them into like, okay, so the more intelligent, less intelligent, etc. and so forth?
Technical knowledge.
Okay. What else?
Usually performance in the test and other things.
Their
Okay,
grades.
Performance. Okay. So performance, technical knowledge. What else? Okay. So you have certain criteria to say like, so this person is intelligent and this person is less intelligent, right? See, for example, you have a student who can do only good in like this one particular subject, and if he is not performing well in the other subjects, do you call him more intelligent or less intelligent? On the other hand, you have one student who can like, okay, so he's scoring out in almost all subjects. Who is more intelligent? You got the point, right? So typically, like, okay, so we categorize the person as a intelligent, smart. So depending on the either it could be based on the a specific task or a collection of tasks. So whom do you say like, okay, so the what is that, uh, super student? So
Good
typically, like,
task.
okay, so yeah, yes.
one who
You
does
should
in
be.
all the he will be good, but
You should be.
one who goes subject,
Hmm.
then it would be done in that particular subject.
Right. Okay. Let us come back to that actually. Now, uh, uh, but definitely there is some criteria for you to judge some person as a more intelligent and some person as a less intelligent, right? So in the similar way, even the algorithms, especially intelligent algorithms, can be classified into different categories. Okay, so different types. So the first one is the artificial super intelligence. Okay, so what is this artificial super intelligence? So, artificial super intelligence, if I define, it is an intelligent system which can, which will be smarter than the best of human brains. That means these are the categories of algorithms which outsmarts the human in almost all tasks. Okay. So, what is this almost all task? Let us try to see. Like, okay, so before we, for better understanding, let us try to see. So we call ourselves as intelligent algorithm, intelligent animals, right? Okay. So now, as a human, like okay, so as a person, you know how to uh, ride a bike, how to ride a car, how to cook. Okay, at least to some extent, and you know how to play a particular game, etc. and so forth. Now, is riding a bike an intelligent task or not? Does riding a bike require intelligence? Do we
Yes,
really
sir.
need an intelligence to ride a bike? Why you need to have intelligence to ride a bike?
To understand the mechanics.
Really? See, for example, do you ride a bike, scooter, madam?
Yes, sir.
Okay. So, do you know the mechanics of that scooter?
To some extent, sir.
So, what mechanical or the mechanics of the vehicle you are aware? See, basically,
Accelerate.
all you know is like so. You need to where
Ac-
it has to be like so the start where to insert the key. How the
yes.
vehicle has to be start. Vehicle has two wheels and where to fill the fuel, etc. and so forth. Right.
Yes.
Beyond that, you don't know like so the internal how the combustion engine works, or whether it's a two-stroke, four-stroke. What is the difference between two-stroke, four-stroke? But still, I'm not talking about like the internal mechanics of the bike. I'm talking about the activity of riding itself. See, for example, now you are starting from your home. So you need to go to college. You are riding a bike. So to ride a bike from college, from your home to college, do we really need to have intelligence?
No, sir. No, sir.
No. All of you agree with that answer?
Moses says some intelligence is required,
What is intelligence?
like the way we will manage the direction, the way we will take the direction, and will compete with other those who are in the road. So some
Mm.
intelligence we need to ride a
Mm.
bicycle.
It's not some intelligence, madam. It's a more intelligence. So you need to perceive. You need to see like where you need to
You need
distinguish
to
between
read the
like okay, so the
environment.
person or whether like if there is a dog in the street, you need to
Yes.
not only like recognizing a dog, you need to also predict whether the dog will like okay, so chase you or like it will cross you or whether like what will be the direction of the dog is expected to move. Based on that, you need to decide whether I need
Yes.
to accelerate or I need to avoid the brake, apply the brake, or I need to take a different course. Yes or no?
Yes.
So that means even though like the simple act of riding a bike requires multiple decisions, when to apply the brake, when to accelerate, how much acceleration has to be given, where is the signal light, when to stop, where to stop, is there is any vehicle, whether the vehicle is moving in what direction, what speed, pedestrian, animal, and you also need to see like okay, so whether your vehicle can pass through that narrow lane of road or between the barricades. Yes or no? These are the kind of decisions you will try to make during the riding of a bike, right? So that means all these activities require lot of decision making. Okay, hence, so it is a definitely it's a intelligent task. Intelligence is required for performing the task. So similarly, cooking. Does your cooking require intelligence?
Yes, sir.
Why?
Because how much
Why?
salt we have to, how much water we have to add, everything we have to decide, and how
That
much.
is fixed, right? For example, like okay, so if I want to make a rice, I take 1 cup of rice, put two portions of 2 cups of water, close the cooker lid, switch on the what is that stove. After two whistles, turn off. No intelligence. Do you think really it requires intelligence? Of course, it requires intelligence because not because of like okay, how much salt or the other things you need to put. Of course, like so you in order to invent that improvise that recipe, you need to know like so what ingredients has to be put in what sequence. The real intelligence comes in a much more later stage. So you are planning to cook a sambar and you put more salt. Now sambar is more salty. You want to adjust it. What you will try to do? See, that's where the actual intelligence comes actually, right? So most of the time, like okay, so you are cooking and the sambar is salty now, so you know how to adjust it, right? Either you try to increase the water or you try to put some other ingredient to balance it out. Okay, so even cooking task requires a lot of intelligence. Okay, like this, as a humans in a day to day, knowingly or unknowingly, we are performing lot many such kind of intelligent tasks. Now, assume that when I say artificial superintelligence system, artificial superintelligence systems are the systems which can perform these kind of multiple intelligent tasks. Not only performing these kind of multiple intelligent tasks, it can outperform humans in almost all possible way. It can perform multiple tasks and it can perform much smarter than humans. If that is the case, then we call such kind of artificial intelligence systems as a artificial superintelligence system. Now the question is, do we have such kind of systems available today? What's your opinion? Do we have such kind of systems exist today which can perform multiple tasks as humans can do, and it can perform in a much better way than humans? What do you think? Those kind of systems are available or not available? So those kind of systems are not commonly available. They are in the process of building this kind of systems. Probably like okay, so as per the some of the research studies and like so the expectations, so these kind of systems may become reality. Maybe somewhere like so maybe in another 5 to 6 years. Okay. So as on today we are talking, artificial superintelligence systems are in the process of building. Those systems are not widely available today. Okay. The next category of intelligence is okay, they are intelligent system. They work on par with the humans. They can perform multiple tasks, not a specific task, but they can perform multiple tasks. It can play guitar, it can play flute, it can generate some content, it can do some kind of operations, like it can do multiple tasks. Okay, so it can also like okay, so the produces the result approximately like the acceptable result. Okay, so sometimes it makes a mistake, sometimes like so it can perform like so it can generate the performance which are acceptable at human level. Okay, if that is the kind of systems, then we call such algorithms as a artificial general intelligence. Why general? Because they are not built for a specific task. They can perform general tasks like task 1, task 2, task 3, task 4, etc and so forth. So it is not tied to a specific application, so specific domain. It can perform multiple tasks. You can ask, you can get the information for task one. It can you can ask to solve the task two. It can you can ask the physics problem, etc. and so forth, and it will be able to solve all these kind of problem. So sometimes it can make mistake, but the solution is on an average is acceptable level for the humans. If that is the case, we call such systems as a artificial general intelligence. What do you think? Like these kind of systems are available today? Yes. No.
All right.
No. Are you sure? How many of you are using GPT, GPT or
Alexa,
Gemini?
Alexa,
Alexa. Alexa. Okay. Uh, so if you're familiar using Open Chat GPT or Gemini or Copilot,
ChatGPT we are using, sir.
for what you are using? What is the task you are like? For what purpose you have used Chat GPT?
For lecture assistance, sir. For
Okay.
taking notes,
Okay.
writing content.
Writing content. Okay. Any for any other purpose you have videos?
Error fixing.
Huh?
Sir, error fixing.
Error?
Sir,
Error
error fixing in code.
Okay.
programming.
Program. So fixing the bugs in the program. Okay. So don't you think that both of them are different tasks? In the first one, you are using the GPT or like so the so-called like so the algorithm to generate the notes or the content. In the second one, like so you're using it for the fixing the bugs in a program. And similarly, like somebody might have used it for like so to make a travel itinerary. So somebody may be using it for getting the recipe, etc. and so forth. That means so we can ask the different type of questions, and you will still get like to the answer from the this system. So sometimes answers are acceptable. Sometimes answers may not be in a truly acceptable level, but by large, so these kind of systems, you still like so produces the result at the acceptable level. Okay. So that means what I'm trying to say, like so yes, as somebody mentioned, like so then general intelligence systems are also in the process of building, but we are very close to that kind of general intelligence. Already we are having those kind of systems in terms of a GPT, but the only restriction with that kind of systems is they are only like so producing the result. It will just give the response. It will not act. Humans, we also act, right? So that's where I think probably like I will touch upon those aspects. Like so, we are talking about how to translate physical. We are talking about the physical AI. Physical AI means how to translate this to like so the physical systems. Okay. Now putting into the robots or like so the. So of course there are some general intelligence. The actions are also being implemented for a specific cases like now you are having autonomous driving cars, so we have a cleaning and mopping, sweeping and mopping robots. They are intelligent. They are performing the action, but they can perform only specific tasks. You cannot ask like the sweeping and mopping robot to drive a car. Okay, so but again, like so, the by large, the general intelligence systems are not widely available as I we talk today, but like so maybe in another year or so, probably these kind of systems will become more common. Okay. So the last category of intelligence are the least type of or the like the least impactful intelligence artificial intelligence system is artificial narrow intelligence. These are the systems which are very specialized, like so they are very specialized to perform a specific task. That means if I build a algorithm to recognize the faces, it can only recognize the face. It may not be able to recognize the voice. If I build a system to recognize the handwritten handwriting, it can only the read in the handwriting, but it may not be able to read it. Okay. So if I have like okay, so for example, if I have built algorithm to recognize English letters, probably it can recognize only the English letter. Probably it may not recognize Chinese or Japanese language scripts. Okay. So these are the systems. These are the intelligence system. Like so, we call it as artificial narrow intelligence system, which are very abundant. So in fact, your most of your machine learning algorithms are comes under the category of artificial narrow intelligence because so when we try to do the machine learning algorithm development, you try to build the machine learning algorithm for specific tasks. For example, if you are working on face recognition, you will try to train a algorithm or the model only for recognizing the faces. It can recognize only the face with whatever the percentage of accuracy, but it may not do the other tasks. Okay. So if that is the case, we call such kind of algorithms as narrow intelligence because it is very narrow to a specific task or very specific to specific application domain. Clear? So just like how we categorize the humans according to their the different levels of intelligence, so even the artificial intelligence can also be broadly classified into different levels of intelligence. Either it could be narrow intelligence, general intelligence, and super intelligence. Clear? Any questions so far? No? Okay. So if no question, I think probably this is what the machine learning basics. I will just quickly skim through this. So, as most of you are familiar, so by the way, like, can I safely assume that okay, so you are familiar with the fundamental concept of machine learning, or if any of you are not familiar, let me like take some time to explain. Otherwise, I will just try to skip it.
I don't know about this machine stuff, sir.
Okay. Like just for the sake of some of the, say, typically the machine learning means there is a learning involved, right? So we need to learn what you are trying to learn. See, for example, when you go to class, if you are taking a subject, when the student first time comes to the class, he is not aware of the concept. How are you going to teach him about that concepts? You give like, okay, so you explain the concept. Okay, this is the concept, and you probably like first you will explain the concept, and then probably you will take some example, and you will try to see like, so how to apply this concept to this example type problem, and try to get the result. Yes or no? So this is how you teach, right? So first, this is the concept. You take some sample example problems, maybe one, two, three, some example problems, and you will try to explain how to apply this concept on these example problems to generate the result. What is the expectation? The expectation is, what is your expectation when you are trying to explain the concept through this example? Do you expect your student to be familiar with only these examples, or you expect him to learn the concept so that he can apply this concept to solve some sixth problem, which is not even considered actually? What was your expectation when you are teaching this concept? So your expectation is not only familiarity with this example problems only, you should be able to apply and solve the other problems also, right? So in the similar way, even the machines need to be trained or taught in the similar way. Okay. So to do that, we have something called labeled data. Labeled data means these are the example problems. For this, I have given the problem. I also know the answer for this problem. Okay. This is the concept. I know that I explained the concept. I given the problem and also given the solution. All you need to do is how to apply this concept to this problem to get this output. So if by applying this problem, this concept on this problem, and if we get this result, then we say, okay, he is able to solve this problem. So similarly, we take the second problem, apply the concept, produce the corresponding output. That means the labeled data means like, so for the similar case, even the machine learning algorithms requires a lot of labeled data. Labeled data means I know like I have a problem, and also corresponding answer. If for every problem there is a corresponding answer is also known, then we say it is a labeled data. Okay. Using this labeled data, apply the concept and try to train the algorithm, train the machine. How? See, for example, this is my problem. I have a concept. I apply the concept on this problem. I got the result R. I will check this result R is matching with this result or not. Okay, the labeled result. If result is proper, okay, yes, this is solved. If result is not proper, then he has to go back, resolve this problem. Because his concept is not yet understood properly. To solve this problem, he will repeat. How long? This process will be repeated as long as he is able to get the result, get the answer without any mistake. Then we say, yes, he has learned the concept. How are you going to evaluate this? Whether the students are learning or not in the classroom? So that means why I'm trying to take the example is even in your classroom, like so you can consider each one of your students as a machine learning algorithms. You are a supervisor. overseeing that process of learning. How do you do that? So initially, when the syllabus, when the semester starts, you explain the concept, you give the example, and ask students to learn. So somebody has to evaluate it, right? How are you going to evaluate? You conduct the internals. In the internals, what you will try to do? You will give some other problem and try to see whether the student has learned the concept or not. If the students, most of the students are not performed well, what you will try to do? You will do the revision in the classroom. So that's what it is, the learning. So this training process is an iterative process. It will keep on continue as long as the training is proper. See, sometimes whatever you do, like okay, so in your classroom, so some students are not able to achieve the result. They will not be able to. So most of the 90% of the students are able to understand the concept, but 10% they are not able to catch up the concept. Are you going to continuously work till you get the 100%? Probably no. At some point of time, you will stop. Okay. So that's what, like you say, the tolerance. That means, so you keep some target. So I want to get 90% target, 90% accuracy for this algorithm. If as long as 90% is achieved, I will stop the process. In the similar way, even in the machine learning, we take the labeled data, apply the machine learning algorithms on an iterative basis to see whether the system is able to learn the concept. Okay. Once that is done, so we save that learned model. That means concept is learned. Now I give like unlabeled data. So it's there is a typo here. It is not a labeled data. It's unlabeled data. That means this data doesn't have an answer. It's only a problem is given. For that, answer is not known. What I will try to do, I will try to utilize the learning to give the result. If this works in a real mode without any failure, then this can be deployed for the operation, real operation. Okay. So in other words, so initially, like so the machine learning as a stage of training and prediction. This is basically like so the testing part, and the testing is successful, then we put it into the deployment. These are the three stages. This is how we train most of the intelligent algorithm. Whether it could be GPT, whether it could be your CNN, or even it could be like so your the simplest case of a support vector machine or neural networks. All the algorithms works in the same principle. We have some data, labeled data, apply the learning algorithm, solve the problem, get the learned model, evaluate. Once the evaluation is successful, then you can deploy it. Clear? So again, like so the machine learning has got different type of learning. So again, we have something like so we call it as a supervised learning if you have a labeled data. That means for every data training samples, you have a label data available for the label. So then we call it as a supervised learning. So sometimes you will have only data, but you don't have a labels. But still I need to perform a machine learning task. So in such case, we try to understand the pattern or the for the unlabeled data, and we call it as a unsupervised learning. Unsupervised learning is basically the similarity of the pattern. We try to group the data. Okay, I will not get into the details, but if I try to get into the detail, each learning, supervised, unsupervised, reinforcement learning itself is a topic by itself. You can spend like so a entire semester for this. So probably like so the at the year level, supervised learning means so you will have a labeled data for training. Unsupervised learning, again the machine learning happens, but not based on the labeled data, but based on the similarity of the patterns. So it is similar to like okay, so for example, I have all these squares, but all these squares are in blue color. Then I will try to group this as a one category. What is the criteria I consider? Okay, they are square, but they are all blue color. These are also square, but they are in a different color, yellow color. It will come under a different category, and these are comes under the different category. But when I start the process, nobody has given the information about the okay. So these are the yellow color square, blue color square, or the red color square. I have just observed and see like so these are having similar. I will try to let me group it into one category. These are all like so one having similarity. I will group it into another category. If that is the kind of learning or the algorithm you are trying to develop, then we call this as a unsupervised learning algorithms. And the last category or another category of learning is, so sometimes learning doesn't happen on a single basis. I give the instance, and if it is result is successful, I will say it is a learn, or like we said, I will repeat the process. Sometimes it requires to observe like so sequence of operation. For example, um so which example? So, are you familiar with cleaning and mopping robots? Any of you have a experience using this kind of robot to, so cleaning and mopping robot is nothing but like was a simple robot, so which can perform like with the sweeping instead of you sweeping. So the robot will perform the sweeping and it will like with the mop. So usually like so if it is
Vacuum cleaner.
manual process, yes,
It's like a vacuum cleaner, is it?
yes, it's a vacuum cleaner, but vacuum cleaner is not operated with the human by the humans. It will automatically do,
Okay.
right? So I think like now nowadays I think these are very commonly available. Like I think probably for as low as like for 10 to 12,000 rupees, you can get those kind of robots which can
Yes,
perform
sir.
the sweeping and mopping. Okay,
Yeah,
so
yeah.
what it will try to do, it will try to map your entire floor of the house. It will design the path in what path it has to clean. Now you are trying to see like okay, so you purchase one such robot, you need to evaluate on what basis you will try to evaluate this robot is working properly or not, or like that vacuum cleaner the vacuum mopping
The
cleaner
performance is depending upon the degree of cleanness. The
cleaning.
way
Okay,
the, uh,
okay, it has cleaned very well at one location, but all other locations it is not properly cleaned. So do you say like so it's a good robot?
no, 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 sir.
Okay, so that means, so you will try to see like so whether your robot is performing very well on an average basis, not only today. So that means like so you need to evaluate like for a certain period of time, right? So at some location it is not cleaning properly. That means that particular location requires more training or more. It has to mop twice in that particular region. So this is the kind of thing you need to give. Like okay, so there are certain tasks, intelligent tasks, which cannot be decided on the one instance. The result of the one instance. I need to collect a sequence of operations, sequence of like whether it has cleaned all properly, room one, room two, room three properly, then only I will be able to reward this robot. Oh, yes, this is working properly. Okay. So similarly, like okay, so probably all of you are familiar with the chess game, right? Just now I made a first move. The game has just started. I made a first move. Can I decide like so whether he's going to win or lose the game? I cannot be able to decide, right? So basically, I need to observe sequence of moves before I to decide okay whether I am going to win this game or not. Okay, so in such kind of cases, we try to use a kind of learning called a reinforcement learning. Reinforcement learning is a process where the learning happens based on whether the goal has been reached or not, final goal has been reached or not. If the goal has been reached with a minimum number of or optimal number of steps, I will give maximum reward. If the goal is not reached, I will penalize the robot to perform the more tasks. Okay, it's a kind of a reward and penalty kind of framework. So where this systems happens works in the real mode, real environment, it will learn through the environment, and every time it performs the task, I will reward it. Every time it fails to perform the task, I penalize it. So final policy is the one where like so the robot gets the maximum point, right? So that will be considered as a optimal sequence to be ported onto the algorithm for the deployment. Okay, if that is the kind of learning, so then we call it as a reinforcement learning. Clear? So these are the different categories of learning happens. I think probably if you take any of your machine learning tasks, okay, including your GPT, Gemini, or whatever the DeepSeek, right? So internally they use one of these three types of learning. Okay? Any learning in training the artificial intelligence system can broadly be classified into one of these three classes categories. Okay? Any questions?
No, sir.
Okay. If no questions, I think probably we will uh, move on. So one category of algorithm under the category of supervised learning is the neural networks. Why it is called neural network? Again, very interesting story. Neural network means so human brain is the computer in a human, right? Like so, brain acts as a computing or the core to process all the information. So in the similar way, brain has got like several cells called neurons, and all these neurons are interconnected, and these neurons process the information in parallelly to generate the action. How the brain works is so typically we will have sensory organs. So brain receives these sensory inputs from the different uh, sensory organs, like if it is from an optical, so through the optical nerve, it will go to the middle of the brain, and like so that information will be passed on to the neurons, and neurons will try to process these signals and generate the output. For example, your eyes is showing the picture of approaching tiger. Then the this, output generated by the or the response generated by your brain is okay. There is a danger. Try to run or get into a safe shelter. Okay, so that's how your brain works. So utilizing that like so in the similar way. So the neural networks, artificial neural networks, are built to mimic the working principle of human brain. Okay. So just like what is the structure of this neural network? So just like the structure of human brain. So we have something, some layer where the inputs will be given. So just like okay, the human brains get the input from a external source, right? These are the neurons. These are the cells. These are the nodes which are responsible to get the input from the external source. Okay. And similarly, so we collect the output from some source, some nodes. Okay, these are the nodes which are responsible for collecting the outputs. And there are some neurons, just like a human brain cells, right? So the neuron cells. So there are some cells, so which are not accessible from the outside. They are called hidden layers, hidden neurons. Okay. So typically we have some neurons here marked in the yellow color are called input neurons. The red ones are output neurons, so which are accessible from the external source. And these nodes, which are in green color, are hidden from the external source that cannot be directly controlled from the outside environment. Okay. All you can do is you can just give the input from the external source through the input neurons, and you can collect the response from these red color neurons or red color nodes. Okay. These nodes has a very special property. We'll see like so what kind of special property it possesses. It will try to perform the process on the input to generate the output. How the learning happens? It takes the input here, it process and try to compare the output. So we mentioned about the supervised learning, right? So that means if I give this input, I also know like what should be the output. If these neurons generate the output, expected output E, expected output EO, so then result is acceptable. If it generates some other output Y, then it is not acceptable. So then what we will try to do? So I was expecting E, but it generated Y. The difference between them is called some X or the error. This error has to be communicated back so that these neurons can adjust their weights to generate the proper. That's how the learning happens. Okay, clear? So I will not get into the detail like so again here probably like if some of you are interested, I think you can just go through what is the working principle of neural network. So in a nutshell, so neural networks mimics the human brain functionality where outputs are collected at this stage. So I try to take the input and generate the output, and generated output compared with the expected output or the desired output. And if the desired output and generated outputs are proper, then it is accepted. Otherwise, it will be iterated back. So iteration, when it iterate back, we are not going to change the inputs. Inputs are same. Outputs is also same. Only thing is there is something called we call it as a weight. This weight has to be adjusted. So simple analogy I will try to give it here at this point of time. So assume a case as a human being. See, for example, you have seen some person long back. Like so, for example, like so, there is a good friend of you. He was in your primary school. After primary school, you never met him for like let us say like you are in 30s or 40s. That means for 20-25 years you have not met that person. After 30 years or 25 years, if you meet that person, so you will always feel that okay, somewhere I have seen this person, but I am not able to recall. Have you experienced this kind of behavior from yourself at any point of time? Hey, alright, this guy I have seen somewhere, but I am not able to recollect. Yes, sir. I think most of us, one or the other point of time, we might have encountered that. So, what makes that kind of behavior? That means, so for some persons, some faces, it requires more effort to recognize. On the other hand, you meet some persons on a day-to-day basis. For example, your family members. You interact with them on a daily basis. See, forget about seeing. Even if that person is talking somewhere like so 20, 30 meters away, just by listening like so, slightest the voice pattern, you will be able to say this person, right? So that means for some instances, you are able to recognize very fast with little effort, and some instances you need more effort to recognize. Because of that factor, like so, these weights, right? We call it as a synaptic junction. So if the same pattern is being repeatedly seen, these two neurons become so close, the information can easily flow from this neuron to this neuron. On the other hand, if you learn the concept or the person, but after some certain period of time, they're not interacted on a regular basis, the distance between these neurons grows. Okay? Because of that, the bridge becomes wider and wider. So it requires more energy to pass the information from this neuron to this neuron. So that's the exact scenario like which I was trying to explain you. Like okay, so some instances it requires lot of effort to recognize that person. Okay, so I met somewhere. Okay, then after some putting more effort, you will be eventually able to recognize that okay, oh, this is the person. On the other hand, like so some person you can easily recognize. So because of this, something called like the synaptic junction. In case of a neural network, we try to adjust that kind of behavior using the weights. Clear? So that's the working principle of neural networks. So now, what are the challenges in a traditional machine learning? Now I'm trying to move from traditional machine learning to a deep learning. So in a traditional machine learning, there are certain problems. So every time you need to have a domain expertise. What is this domain expertise? You need to like, for example, if at all you want to recognize the face, you need to extract. You need to know like so what kind of faces you are expecting, and also you need to decide what kind of features I need to extract. Okay, these are the eyes, nose, nose length, mouth region, chin, etc. and so forth. Hair color. Okay, these are all the features you are trying to define. Okay, so the hair color, eyes, forehead, nose, lips or mouth, chin, they are formatted. So the distance between the eyes. These are the kind of features you need to extract. Okay. So you need to extract manually. Okay. So to extract manually, you need to also know like so what is the face structure, that kind of domain expertise is required. And then you also need to decide what features are suitable. And then we also need to understand about the computation curve. This is very, very important. Like so, this is where the optimization comes into picture actually. So you need to also consider like computation complexity. For example, why computation complexity becomes very important is see some recognition, some tasks requires real-time operation. For example, you are having an autonomous driving vehicle, and your vehicle is moving at 100 km per hour. If there is an obstacle, it should detect at very precise time, and it should also act like we should generate the response in such a way that so you need to apply the brake immediately so that like so the vehicle can come to halt from 100 km per hour to maybe like so less than like so zero in a maybe like 2 seconds or 3 seconds. Otherwise, uh, you know the eventuality, right? So computation complexity also very plays very important role. Okay, and like of course there is a difference between feature extraction and learning. So these tasks make the traditional machine learning very difficult. So why I'm trying to stress upon is see probably if you look into the overall evolution of computing, right? So initially most of the computations were done by ants. So humans were able to do the calculation up to certain extent. Then calculators were invented. Why calculators were invented? At that point of time, the calculation or handling the large numbers was very difficult. So that's where the calculators were invented. So then, even to use the calculators every time is cumbersome. So people felt like, okay, so is it possible to automate this process of calculation? So that's where your computers, early computers were invented. And these computers were able to like, okay, so you can feed the steps and it can perform the calculation and give the result. So it solved the problem to some extent. But again, people are thinking, okay, so again, every time I need to write a program, writing program is a cumbersome. Is it a way to automate this? Can I solve the problem without writing this program? That's where your traditional machine learning algorithms came into picture, where you give the inputs, set of sample data, and from this sample data, the program was learned. But for this sample data mapping, you need to still perform these kind of tasks. Getting the point? So people were not even happy with this kind of machine learning algorithms. They want still like so the simplify the task. That give birth or the lead to the development of a very interesting concepts of the deep learning. Clear? So if you're able to understand, right, how the evolution of computation happened. Because as a
Sir,
humans,
one question, sir.
yes, madam.
Please, sir, clarify with an example what is actually the gap between feature extraction and learning? Because I'm thinking that the feature extraction and learning they're directly proportional. If we'll extract the feature properly, then learning will be proper. What we have learned. So please clarify what
Okay.
was
So
the gap
say for
between
example,
gap. Hmm.
here the learning means I am talking about building a classifier.
Okay.
Okay. So your classifier could be like either it could be a neural network or it could be SVM. Whatever the classifier it is. Like so, for example, if you are familiar with the machine learning, there are hundreds of classifiers, right?
Yes,
So
yes.
this is my classifier. I have decided to use one of these classifiers. Let us say neural network.
Okay.
What does the neural network takes as input?
So it will take the input features, input images,
It
features.
takes numbers. It can take any number. It doesn't know that doesn't even know like so for the low level implementation wise, it doesn't even know like what is the whether it is a feature or it basically takes set of numbers. Agree?
Yes, sir.
Right. So what do you mean by feature? Feature is a representative of the data, right? See, for example, I have an image. In this image, I want to recognize the face.
Yeah.
Whether this is a face of person 1, person 2, person 3, etc. So, agree? Right?
Yes.
Somehow, I need to convert this image into this kind of representation, a numerical representation. How do I do that numerical representation? So I will try to run some algorithm to detect the eyes. Okay. Eyes length. Okay, that is the length of the eyes is feature number 1. Okay. So the length of left eyes and right eyes is feature 1 and feature 2. The distance between these two is another feature. Okay, that means feature 1, F1, F2, F3. Similarly, like okay, so the nose length is feature 4, etc. So at the end of the day, these are nothing but numbers, right? Right? So these are extracted by whom? You have extracted, you have written some image processing algorithm to parse and detect the eyes and convert those eyes into like okay, so the eyes length and you generated some number. So similarly, this and this neural network, you have decided the architecture based on the extracted feature. So for this neural network, it takes it just as a number, just numbers, and try to compute the output. So now, from this image to this representation, there is a gap. Yes or no? This could be gap, right? See, for example, if I give this image to somebody else, he may generate with he may come up with some other representation. Agree or not? Right?
Yes.
So the perceptual difference between like so the actual scenario, like so the moment you take the image itself, there is already a gap. In the real environment, the face is a 3D, but the moment you take a picture, it's a 2D. There is already there is some gap. It's an approximate representation of face in a image form. Agree? Already some gap has been generated here. Now, this image, you are trying to represent it in terms of some numbers. Based on what? Based on your domain expertise. So, how did you decide like so? These are good feature to recognize. Probably you feel like okay, eye length, the distance between the eyes, nose length, and the formation of this, the spatial relationship. So can recognize a face because every person may have like so this different type of eye length, eye distribution, etc. and so forth. This can be a good feature for you to decide on whether this is a person one, person two, etc. How did you acquire that? Probably you acquired based on the domain expertise. Okay. So now you decided how many features you need to extract. So you also know like so if there is a so similar kind of person with similar distance, so then probably these features are not sufficient. You will try to add another feature. Okay, hair color. Okay, so that's how you try to keep on adding the feature. So
Okay.
now representing these features, there is a gap. Now the gap between like so the learning algorithm just taking this as a numbers and it is trying to learn. There is a gap between your image to this and there is a gap between like with the way algorithm perceives it. Algorithm like with your classifier takes it as a one vector and trying to recognize it. So now these gaps, as long as like so the gap become more and more, then probably like with the solving problem or the getting the good result may become weaker, or you may need more effort to bridge these gaps. Okay, so that's the beauty. Like so, the deep learning basically try to address or try to minimize these gaps to the maximum extent, not 100% to maximum extent. We'll see like okay, so how this will try to minimize this. Okay, did I answer your question, madam?
Yes, sir. Yes, sir.
Yes.
Thank you, sir.
Okay. So any other questions? If no question, I think probably we can quickly move on to the deep learning. So basically, in case of a traditional machine learning, so this is the sequence. So you have input, manually we extract the features, you decide the classifier, classification happens, and then you will eventually get the result. Whereas in case of a deep learning, even this manual feature extraction has been avoided. Okay. So just give the input. So the deep learning algorithm will decide what features has to be extracted, how many features has to be extracted, and how to train the classifier. Basically, the deep learning is not merely about adding more number of neurons. In case of like in this case, only one hidden layer, right? But you are seeing more number of layers here. Of course, like so the deep learning will have more number of layers, but that doesn't make it is a deeper layer, deeper network or a deep learning. So deep learning is basically bridging the gap, eliminating the gap between feature extraction and classification and unifying this as a one single framework is what makes it is a deeper learning. Basically here, these are the classifier part, the later neurons, okay, in the neural network forms a what we call it is a classifier, and the earlier or the initial layers are responsible for the feature extraction. Basically, these two works in tandem. That means I give this as an input. What was expected as output? When I give this as an input, your algorithm should say it's a car. That's the expected output. So now I give this as an input. It has extracted certain feature. It has performed the classification. I try to say whether what is the output. If it says it's a truck, then something is wrong. Then what it will try to do? It will go back and adjust not only the classifier, it will also try to adjust the your feature extraction. Whereas in the earlier case, right, why the gap becomes so when you try to train the algorithm, the traditional neural network, you will try to only try to address the weights of the neural network, not the feature extraction. You got the point? Where the gap comes into picture in the case of a traditional machine learning. Here, the gap getting minimized, not only like because of the weights of the classifier will be adjusted, the weights of the feature extraction will also be get adjusted. That way, we try to minimize the gap between the physical world and the expected output. You got the point? Okay, so that makes this as a deeper learning. Okay, so of course, deep learning will have more number of layers. More the number of layers, we call it as a deeper network. That's true. But when somebody asks you like what is exactly a deep learning, don't just tell that okay, so the network with more number of layers. Just more number of layers doesn't make it as a deeper network. Basically, it should have a deeper insight. Insight learning should happen. Okay? So that makes a deep learning. Where now all you need to do is just collecting the data. You need not to worry about like so the extracting the feature extraction. You need not to worry about having the domain expertise to extract the features, and you need not to like so the expertise to select the classifier. All these things are getting embedded into one. So that's the reason these days developing a machine learning algorithm or like so the AI solution is very simple. All you need to do is get the data, decide some pre-architecture, train, keep training, and eventually we'll get the result. Clear? So that's how the deep learning works. So it simplifies the task of intelligent task building in a much simpler way. All you need to do is now only collecting the data. Once you collect the data, rest of the problems is almost simplified. Okay. Now we are even talking about like auto ML. Even you need not to decide about this architecture. So if you have like so the multiple architectures, you just give the data to auto ML algorithm. It will try to select. Oh, okay, this architecture is best for this data, and it will try to train itself and give the model. It's as simple as that. Okay. So now we are talking about the agents, right? So that is the problem is becoming much simpler now. All you need to define is okay, this is my problem domain. These are the kind of result I expect. You just define the goal, end goal. Your agent will work with the available LLMs or the deep learning systems to get the response and get the goal lines. You don't even need to select the auto ML process. Clear? So Are you able to get me right? Like, so the direction in which the entire field is moving. Okay. So now building the problem or building the AI solution is not that difficult. All you need to know is what tools, what technology, and how it has to be integrated. Okay. Even for that, you can utilize like so your chat GPT or like so. I don't know like how many of you are familiar with Google's what is that uh, forgot the name. Let me see. What is that? Just give me a sec. So, okay. Are you familiar with this? You are able to see my screen now?
Yes, sir.
Which screen you are seeing, madam?
What is deep learning?
Huh? What is deep learning? Okay.
What?
Okay. So there is like, okay, so Google's this Firebase Studio. Okay. So this basically like, so this is a framework where you can build a project. Okay. Build a complete project just by based on the prompt. See, for example, you are able to see this one, right? Hello, Dinesh, welcome back, Firebase Studio. Yes or no?
Yes, sir.
Okay. No. Still,
Yes,
still,
sir.
okay, so I want to build like, okay, so I want to build a web solution to classify flowers. Input should be image of flower and it should recognize and label name of flower and its okay. Leaves. You got the point? What I'm trying to build? So I want to build a web application, a web page or the web application where it should take the image of a flower and and it should recognize what flower it is. So it is. I didn't even write a single line of code. I just mentioned like so. These are the things I need to do. So now it is building the application. You got the point? So now complete source code is been built. So typically, if this is the kind of project if you are given to students or like so if you want to develop from the scratch to build this kind of application, how much time probably it might require on a rough basis. So you should have like okay, so you should collect the images of flowers. You need to build a AI system to train a learning algorithm to train the flower images, tune that model, and then you need to build application which can take the image of a flower, and then it should trigger the model, and it should give the recognize the flower, and also it should recognize the characteristics of the flower. So, on an average, like so if you give it to the BE students, probably they will spend one semester entire semester project to build this kind of solution. Agree or disagree? Hmm? Yes. I think let's wait for another 2 seconds, maximum 1 minute. I think probably your solution will be ready. Okay. So it has made some mistakes. So it will try to correct by itself. Once it is built, you can just run it. You are seeing, right? It automatically corrects the code itself. If it is not able to execute, it is, see, all these things are happening based on the agents actually. Like, so this is how the agentic way of working happens. Okay. I think probably like you started listening about like hearing about the news that okay, AI will take out the job of many people, right? Even including the programmers because of these kind of things. All you need to know is what kind of problem you need to solve, not writing the code itself. It can generate, it can write. So it is generated the code. Now it is checking for the errors. It is debugging itself. Okay. Yeah. Yes. That's it. Done. Okay. Just upload the image. I don't have flower image. Let me download some image. Let me take some complex image. Okay. Let me take this. What image it is? What flower it is? Hmm?
Tulip.
Tulip, right? Let us see like okay, so whether it gives tulips. That's the answer. So I just randomly downloaded some image. So I will upload flower one. Wait. You need not worry actually. Like everything, it will automatically get it done by itself. Okay, I'm slightly deviating here. Just I wanted to give a glimpse that okay, so what kind of problems can be solved? Like so, what is the current state of the AI development? And all this development was possible because of the very initial work in the area of deep learning. Okay, so that was the starting point. Okay, you want to see the prompt? This was the prompt I had given. I want to build a web solution to classify the flower input. Flowers input should be an image of flowers, and it should recognize and give the name of flower and its characteristics. That's it. That's all the information I had given. Like so, not even like with the second. Wait, I didn't even improvise the prompt. You can always improvise the prompt. So this entire application it has built actually, like it was basically like it has built a web page. So provision for taking the image as an input, and it will try to you can even get complete code by itself actually. So that's the beauty of so even you need not to edit and debug this. You can just ask like so debug the error and fix the code. So it will try to do it. Okay. So probably like if you spend 3 to 4 prompts, right? So probably you will be able to build this complete application. Okay. So that's the kind of let it proceed to build. Let us try to go back and try to uh, proceed our learning. I think probably will come back once it is done. Okay, you got it right. So we are trying to bridge the gap, and like so that bridging gap will help in a bigger way, right? So that's how like because of the your deep learning can solve most of the problem. Like so, if I put it in a simplest form, so what is the main difference between the traditional machine learning algorithm and the deep learning is so the manual feature extraction has been eliminated. Like so, you need not to worry about the feature extraction. So you just give the data. Rest of the things will be taken care with the deep learning. Whereas in case of a traditional machine learning, once you collect the data, you need to manually decide on the feature extraction and you need to define the classifier and you need to train it. Here also training is required, but the feature extraction and training happens simultaneously. Clear? Any questions before we proceed further? Hmm? Okay, right. So if you are already like so very familiar with the deep learning and machine learning concepts, there are a few questions I just wanted to ask. Okay. So now just look at this graph. What are the things you can infer from this graph? Very very interesting concept. I think probably like this is core at like this as a if you are doing machine learning research in the area of AI, this place like was a very very interesting discussion actually. So there are
Then
two graphs
data science,
actually. Hmm?
data is
Yeah.
more,
Yes. Uh,
then this one is very good. Availability of data is more, then we can use deep learning.
okay. Okay. That is one interpretation. Okay. If the data is more, you can go for a deep learning, and if the data is less, you can go for the traditional machine learning.
Performance is high in deep learning, sir.
Performance is high in the deep learning, and performance is not high in the deep learning. But here, let me use a different color. Let me use a different color. Hmm. How do you justify this? Here, the performance of traditional machine learning is high. Why? Even though data is less, traditional machine learning algorithm. See, one thing is clear. So as the data size increases, so we know like so the more the data, better response we can get it. That means more instances for learning, I can get a better instance, better insight. But what about this actually? In this case, my data is less, but traditional machine learning algorithm is giving more better result. And as the data increases, contrary to our initial assumption, so the performance of traditional machine learning algorithm is not increasing significantly. Whereas, like so, the deep learning is in agreement, in line with our initial assumption or the point what we considered. How are we going to interpret this? There are many things can be inferred. Like, so this one graph implies many things. When to select traditional algorithm and when to select deep learning algorithm. That is one. What is the reason for this? You can even discuss. Okay. Any insight you just want to add before I explain that? How did you train the traditional machine learning algorithm? You trained the traditional machine learning algorithm based on your domain expertise. You extracted the features. Based on the extracted features, you trained the classifier. Because of your domain expertise, even the data is. How did you get the domain expertise, by the way? Based on like so the experience you gained by observing the scenarios. Okay. Based on that, you build the domain expertise, and based on the domain expertise, whatever you acquired, you extracted the features. Because of that, even the lesser amount of data, the traditional machine learning algorithms is giving better results. On the other hand, the deep learning, there is no such kind of domain expertise has been given, right? It has to learn from the scratch. So that's why initially it performs very poor until it sees sufficient amount of instances. Okay. You got the reason, like, so why it is performing here good here and why it is performing bad here? You got the point, right? Yes or no? Yeah. Now, can you tell me, like, so when to select deep learning and when to select traditional machine learning, ML algorithms? Anybody want to add the insight?
And availability of data is more, we can go in for this one.
Okay.
Number of parameters are more, sir.
Number of parameters are more. Okay. So here, like, so I have not mentioned about the parameters. Let us try to restrict to, of course, the parameters also plays very important role, but at least we will try to restrict to the data case. If data is more, we can go for deep learning, no doubt. If data is less, which are the cases where data collection is a problem? Cases where like so the data collection is a problem.
In
Many
health
of you are working
sector,
on. Yeah. Yes.
in health sector,
Health sector. Yes. So typically, like probably like if any of you are working in the medical or the healthcare sector, right? So probably you know the pain of collecting the data. Why? Because uh, in health sector, like so, even though like large amount of data is being collected, so nobody is willing to share the data because of the ethical and the privacy factors. Okay. And not only that, even like so other sectors. For example, if you are, for example, if I talk about the Samsung, so on a day in day out basis, we generate terabytes of data, manufacturing data. But I can give the normal product data. But if I want to build a classifier to classify between the defect and non-defect, I can always get a non-defect data because our yield is like so the factory yield is 99.9%. That means like so the 0.01% is our defects. So if at all I want to train a effective defect detection method, I need to wait a long time to collect that kind of 0.01 type of data. Getting the point? So in such cases where collection of a data becomes either it takes too much of time to collect the sufficient amount of data or collection of data itself is a challenging case. In such scenario, if you have a sufficient domain expertise, better to go for a traditional or the machine learning algorithms, which may yield much better result in the deep learning algorithm. On the other hand, you don't have any problem in collecting the data. You can collect as much of data as much possible, and you don't have any problem with the computation resources. Then probably you can always go for a deep learning algorithm. So when your computing resources are restricted, when data availability is restricted or limited, then and you have a sufficient amount of domain knowledge, then you can go for a traditional machine learning. Okay. Any questions? No questions? Okay. If no questions, let me ask a question. See, why the traditional machine learning algorithms performance is not increasing proportionally to the data size increase? Why that is not happening? Got the point? Listen, my question is,
Will be the same, sir.
performance will be the same. Why? That was like, see, whereas in case of a deep learning, it started with a 0, and as the data size increases, the performance is also increasing. Why the same thing, same behavior is not being observed in case of a traditional machine learning, though there is a learning aspect in the machine learning algorithm. Machine learning algorithms also we train, right? There is a learning component. In spite of that, why the performance is not proportionally increasing in case of AML?
Specific domain only, sir.
Rate may not for time.
Yes. Huh?
With respect to time, the learning rate might not increase. It will be same.
Okay. Anyway, your voice was not clear. Okay, let me give the answer actually. See, typically, how did you train the ML algorithm? You extracted the features. You decided that okay, so for this particular problem domain, I am going to extract 10 features or 100 features or 1000 features. These 1000 features are decided and fixed. You are not going to increase this one, right? Even though like so if you increase the data size, so these 1000 features is going to be restricted unless you change these features or the number of features. So the performance or like so the increase of the data size may not significantly add because you already decided to keep 1,000 features or whatever the fixed number of features. That's the reason there is a slight increase in the algorithm performance, but not drastically because this is restricted by predefined set of number of features. Whereas in case of deep learning, there is no such restriction actually. You are not put any restriction. You can learn as many features as possible. So that means basically we call it as a trainable parameters. In case of a deep learning, the number of trainable parameters are proportional to the architecture size, not proportional to the predefined set of number of features. Whereas in case of a trainable parameters, in case of a ML algorithm, is always fixed, which is fixed by the expert, like you, who decided to keep 1,000 features. Clear? So that's the reason. Like so, in case of a traditional machine learning algorithm, the performance is restricted. Okay, probably if you change the number of features, probably it can slightly increase. Again, it may not overshoot the deep learning algorithm because it has more number of layers. It can learn more number of parameters, and it can learn more number of parameters. It can accommodate more number of variations in the data. So that way, it will try to work towards better generalization than your traditional ML. ML algorithms are more or less trying to be very, very specific towards what the domain expert, whatever the domain expert, right? So algorithms try to converge with respect to the specificity of the domain expertise. Whereas in case of deep learning, like so it is allowed to get into better generalization. Okay. All right. Any questions before we proceed further? Okay. If no questions, let us quickly.
Learning algorithm is much strong enough in order to detect these things, sir. Whether the deep learning algorithms are very strong to learn by itself and like that, how to develop that deep learning algorithm.
Deep learning algorithm development is very, very simple. Like so, probably I have some slides. Okay. See, there are like pre-trained models already available. Okay. So these pre-trained models, like so you can take it and you can perform the transfer learning is possible. So that means like the some of the standard architecture, right? RESTnet 14, RESTnet 50 variants, and like similarly, like so you have a VGGNet or Google Net and Inception Net. So these are the different architectures. These are the different pre-trained architectures. You can take any of this architecture, or you can have multiple architectures available. You can initiate the AutoML algorithm. You give your data and set the target and let it try, it will try to decide like so which particular architecture is appropriate for the given set of data, and it will try to select it. Or you can like so the similar kind of problem, like so probably if you see like the RESTnet is appropriate for your problem, then you select the RESTnet and rest of the things it will try to take care of. All you need to decide is what architecture and what data, how much data, and the training mechanism it automatically train to happen. Of course, like so there are some problems you may get into. So if you take if your problem is very simple and you select a very deeper network, then there could be chances of like so your network may become overfitted. So it may try to remember all the data set. So in that case, we need to employ the regularization. So if not, it can even get into underfit. Your problem is complex, and if you have selected very not so deep network with less number of trainable parameters, so then there could be a possibility of your network get into a possibly underfit kind of situation. Then probably you need to increase more number of layers, convolution layers, or the trainable parameter hidden layers. Okay, that way we can solve the problem, right? So basically, like okay, let me also introduce one more concept, like so why deep learning become popular, right? So the question is why deep network? Okay, so why I'm asking is we have something called universality theorem. So the universality theorem states something like this actually. If you have a single network, a network with a single neuron, single hidden layer. So okay, first let us try to understand the universality theorem. Okay, I think probably. See now, the universality theorem says that you take any continuous function f of the form. So where my domain is real number with n number of n dimension. So it is expected to map to the real number the domain, codomain with m number of features. First, let us try to say like so whether this problem statement, this mathematical statement is a ML problem or not. So typically in ML or in artificial intelligence, what is the problem you're trying to solve? So basically, you have extracted n number of features, right? So n could be like 10 or 100, whatever it is. So for example, you are working on the problem of numeral recognition. What is the number of classes in case of a numeral recognition? 10 classes, right? So it starts from 0, 1, 2, etc. 9. There are 10 classes. Okay. So this becomes, M becomes 10 here because I am working on the problem of numeral recognition. So to do this recognition, let us say you decided to extract 100 features. So 100 features is N becomes 100 here. Now what is the problem? For every image, you extract 100 features, you give it to the network, neural network, and it will try to, your output layer will be 10 neurons corresponding to this 10 classes. So the problem is you give 100 dimension vector and it will try to map this into one of the 10 dimension vector. So out of this 10 dimension vector, one of the node will be 1 and remaining will be 0. If it is recognized it as a numeral 2, so then all others will be 0. except like so the number corresponding neuron corresponding to the number 2, okay, numeral 2 will be high and remaining will be 0. Okay, so basically it will generate a 10-dimensional vector. So that way, if you take any machine learning problem, it is of this form: r to the power of n to r to the power of m. So what this universality theorem states that you take any continuous function of the form mapping r to the power of n to r to the power of m can be solved, can be realized by a network with only one hidden layer. You take any classification problem, that means you can formulate any classification problem to this form. So according to the universality theorem, this can be realized, this can be solved with only one hidden layer, provided I don't restrict the number of neurons getting added to this layer. If that is my restriction, if that is the kind of problem, then I can always solve the problem with only one hidden layer. Not deeper network is required. So basically, universality theorem states that. So as per our, there is a mathematical proof for this actually. So according to this, even the mathematically proven solution, so with only one hidden layer, I should be able to solve the problem. But in spite of that, the question is, why always we go for a deep network, not the fat network? If I call this one hidden layer network as a fat network, so why not like so people the fat network is not popular, right? We often hear like deep network or the DL, not the FL. The reason being the deep learning offers the modularity. It will try to break the problem into simple problem so that I can always able to embed my learning in a much simpler and neater way compared to a fat network. That is one reason. And also like there is a mathematical proof also, like the deeper network, not the mathematical proof, but empirical study to show that deeper network works much faster, much better than the fatter network. That doesn't mean that, okay, so the fat network doesn't work, but probably to get the similar result, you may need to add more number of neurons. Okay. So this is one of the optimization aspect we need to always consider. So typically, more the number of layers with less number of neurons in each layer can perform much better solution than having like so the fatter networks, fatter layers at any layer. Actually. This is one of the important optimization aspect we can always consider. When you are trying to build the architecture or building the architecture, try to ensure your network will have more number of deeper. Because why deeper network? Because it takes the input. The first layer try to refine your inputs. The second layer takes this as an input, output of the first layer as an input, and try to further refine. And third layer, it will try to take the input of the output of the second layer as an input and try to further refine. That means every layer there is a refinement happens, and it is working towards the goal. So I will show you that. Okay, this is how it works actually. So this is my input image. The first layer, it extracts some low level features like edges. The second layer takes this as a edge as an input and further refines. Third layer further refines. So the final layers, you can see like so the later layers will have more intuitive information about the data. So that way, the deeper networks is expected to work much better than the fatter network. Though there is a mathematical proof available that fat network can solve all kind of classification problem. So because of these kind of the further refinement and you can even visualize the results in a much better way. The deep networks are more preferred compared to fat networks. Clear? Any questions? Okay. No questions. Let us try to see like so how does the convolution or the neural network works. So basically, like I have 4 inputs here, 4 hidden neurons. Basically, like one summation layer, and one output layer. So basically, how does it works? So the operation performed at each layer, each neuron is very simple. It is sum of product. Basically, try to take the input, multiply with the weight, and add it, and accumulation of all these things subject to the activation function is what is our output. And this is the same operation will be done in almost all layers. That means though so the concept looks like more mathematical, but internally implementation wise it doesn't require more than additions and multiplication, right? So now the number of parameters. So somebody mentioned about the number of trainable parameters, right? So let us see, so this is the four inputs, four hidden neurons, one activation, and one output layer. So typically, if you assume that okay, all the inputs are connected to all hidden neurons, so then number of connections possible is 4 into 4, right? So there is a 4 into 4, 16 weights possible here. That means 16 learnable parameters, and here another 4, and this one layer. So that means the number of trainable parameters for this kind of setup, where my input is 4, one hidden layer with 4 neurons and one output neuron. So in this, if this is the network architecture, the number of trainable parameters will be about 21. 4 into 4, 16 plus 4 plus 1. So totally 21 trainable parameters available. Clear? How to decide about the number of trainable parameters is based on the number of connections. Now, let me give a very, very interesting case. Let us say I have a image. The image size is only 400 by 400. Very, very modest image, 400 pixel by 400 pixel, and 3 corresponding to 3 channels. If I consider each and every pixel as an input, as a number, you know what is the number of inputs it translates to? It is 480,000 inputs. That means if I just take each and every pixel as a one number and organize it as a feature vector, then the number of inputs translate to about 480,000. Assume that so I will use the same kind of simple network with only one hidden layer with same number of neurons in the hidden layer, 480,000. You know what is the number of trainable parameters in this case? So it's very simple. So it takes the image. I just translate this image as a one-dimension vector by converting each and every pixel as a value. And I have only one hidden layer with 480,000 neurons and one activation layer. Basically, my problem is to say whether the input image is an indoor image or an outdoor image. If it is 0, it says it is an indoor image. If it is a 1, I will classify it as an outdoor image. That's the simple problem. But if I try to give this as an input, the number of trainable parameter becomes about 230 billion. Billions of parameters. Getting right? So training the images in this traditional neural network form is catastrophic. You won't be able to achieve this. Okay. And as the number of images, the image size increases, again, this number of trainable parameter increases, which becomes unmanageable. So that's where the convolution layers, convolution neural network helps actually. So it will significantly reduce the number of trainable parameters, yet able to. So what is convolution? Convolution is basically a set of filters passing through the image. So this is the image pixel. I place this filter and pass on to the image. I just slide the image through the entire the image and compute the response at every location. If I perform that operation, convolution on this filter, this is the output. So just to understand the convolution better way, so assume that okay, this is the image and this is your filter. So as I mentioned, it has to slide over the entire image, right? First, I will try to place it at this location. So now W1 is the weight, A is the pixel intensity, W1 into A. Just like, okay, so it's also like, again, convolution operation also, I am trying to perform the same operation. Sum of product, W1 into A, W2 into B, W3 into E, etc. and so forth. So you will get the response. Response I will copy it here. This is the output image I am forming. Then I move the filter to the next location. Repeat the same process. B into W1, C into W2, F into W3, G. So then you will get response H2. You copy it into location. So now, in a similar way, you can compute for all the cases. Now, what are how many learnable parameters? Only 4 learnable parameters, right? W1, W2, W3, W4. The earlier case, the learnable parameters is as big as the number of images actually. Now, the learnable parameters becomes only 4. If I use one filter, only 4 parameters I need to learn. Now, if I want to use another filter, you select and so many number. Even if I use hundreds of such filters, the number of learnable parameters becomes still 400. So, and the parameters doesn't change with respect to the image size. Even if you apply it for 5 by 5 image or 5000 by 5000 image, the number of learnable parameters still remain same. This is yet another way of optimizing your neural networks for the image handling. So through the convolution neural network, you can always contain the number of trainable parameters in spite of increasing the number of filters. Clear? So again, like so some of the hyperparameters you can always consider to keep the optimization intact. So the depth. So whether what should be the depth of your filters? Whether you want to use 5 filters, 10 filters, 100 filters, 1000 filters. Okay. So you can control stride. So stride means like so whether you want to keep overlapping or you can skip. So here in this case, we've overlapped, right? One filter to another filter, there is a overlapping section. So sometimes if you feel like, so it is not very necessary to have that kind of overlapping features, you can even increase the stride. You can increase the sampling so that you can increase the, reduce the number of iterations to go through and thereby you can even reduce the number of parameters. And also zero padding, whether you want to have a zero padding at the borders or not, that can also like so significantly reduce the number of parameters. So by controlling these parameters, you can still solve the problem, but you can optimize the number of trainable parameters required for the training. You can accelerate the training process by containing this. Yet you can increase the overall accuracy of the result by increasing the depth, controlling the stride and zero padding. So yet another way of optimizing your network is to the pooling operations. So pooling operation means, say, in this case, I generated this result, right? I don't want to keep all the result as it is. What I will try to do? So this is my convolution output. I give the size input to the pooling operation. I don't want all these 4 values. Rather than I want to select one of the maximum among this as a representative. Okay. So if I use the 2 by 2 filter, so here among these 4 value, 5 is maximum. I will just take 5 as a maximum, 5 as a representative. In this case, 4 is representative, 4 is maximum. Here 5 is maximum. Within this region, 3 is maximum. And this is in this region, 4 is maximum. What I did, first I perform the convolution. Upon convolution, I'm not keeping all the convolution results, rather than I'm trying to take the maximum within that region. So in this case, it is a max pool operation. So thereby the size of the output or the size of the input for the subsequent layers are significantly reduced. This is another way of optimizing your input size for training your networks. Right? So some of the tips to train your deep neural networks. So you can always use a different activation functions. So I'm not getting into the details of this activation function because that itself is a very big topic. So you can have hundreds and thousands of activation functions are available. So what kind of activation function to use? So sometimes like so to avoid the overfitting and the saturation, you can use a ReLU or the leaky ReLU kind of activation functions. Learning rate. So this is another factor which can take significant time for training your network. As part of the optimization, what you can do is instead of fixed learning rate, you can always have like this of the dynamic learning rate. So initially you can have a larger steps, and as the number of epochs increases, you can make the learning rate smaller and smaller. So it can make you can the learning rate could be a function of the epochs. As the initially the number of epochs are in the initial stage of your epochs, you can have a larger learning rate. As the number of epochs increases, you can have a smaller and smaller learning rate, so that you don't get into the problem of missing the global minima. Yet you can converge your solution much faster. This is another way of optimizing your learning aspects. Right. So if I summarize the advantages of CNN, you can perform the transfer learning. Transfer learning means, so if you train a network for one purpose, if you want to extend that for the another concept, you need not to retrain from everything from the scratch. You can always do the transfer learning. You can start from whatever the weights already learned. On top of that, you can train the network, and you can always fine tune the CNN layers by increasing more number of filters. Okay, and also like another interesting thing is, like, for example, you built a CNN for face recognition. Now you want to extend it for let us say satellite image recognition classification. What you can do is change the initial layers, keep the later layers as it is. You can still be able to solve the problem. That will thereby, like, so you can you reuse the same kind of network for a different categories of problem. So that was not possible in case of a traditional classifiers, because in case of a traditional classifiers, you need to do the classification or the training from the scratch. Okay, and you can even use the CNN as a feature extractor. Okay, in fact, like, so your generative AI starts with this kind of aspect actually. Like, so it was used as a feature extractor or through the concept of autoencoder. And in fact, so the deep learning and CNN plays a vital role in moving from, like, so the traditional classification problem to generative AI. So I'm a bit rushing because I need to get into, like, so some of the trends. So any questions, like, say any of this concept, if you need any more detail, let me know so that I can take some time to explain with some example. All good? Okay. So if you are with me so far, yes.
About convolution networks, how it performs. Is it possible, sir, now?
It performs in the sense, like, okay, so performs with respect to what? How to build the convolution network? That's what your question? Or, like, okay, so what will be the performance of a deep convolution neural network?
How this convolution neural networks perform, and you're saying about the advantage, but before that, how it works, how it works.
Okay, so let me, like, okay, I got your point. So typically, this you understood, right? The problem with this kind of network. If I take the image and if I use the traditional neural network, what will be the problem, right? You understood that. Now, to overcome this uncontrollable parameter, we use the convolutional network. Now, how to build the convolution neural networks itself? Okay, so let me try to explain. So let us say I have this image. This image I need to classify it as indoor or outdoor. That is my problem. What I will try to do, I use the first filter. Okay, so some filter, like, so I will explain. I will come back to explain what is this filter is. So I will use this filter and I try to convolve on this image. When I try to convolve on this image, you will get one more output, right? You will get a convoluted image. Okay, a convolution image, you will get it. If I use another filter, filter 2, you will get one more image. If I get another filter, you will get another image. Now the problem is, why I used explained about, like, all the max pooling and everything is, see, initially when you started with one image. If I use 3 filters, I got 3 images. So then for the next convolution layer, the input is not this image. These three images will go as an input. So again, making the problem much more complex. That's the reason, usually, if you look into the structure of a convolution neural network, this is your input, typically image or a video. So you will have a convolution layer 1, C1. What this convolution layer 1 will have? It will have collection of filters. Filter 1, filter 2, filter 3, etc. A number of filters, followed by a pooling layer, P1. What it will try to do? It takes this image, depending on the size of the filter, like so in this case, like in the previous case, right? A 4 by 4 image reduced to 2 by 2 image. So in the similar way, the pooling will try to reduce the overall image size into a smaller image sizes, but number of images will remain same. Right? Now, this will act as an input to the next layer. So next convolution layer will have again same thing, like so the C2 will take all these images and apply the filters. You will have another set of filters. So then followed by pooling layer, etc. and so forth. And then you will have something called flattening layer. A flattening layer is the last layer where we try to convert this entire the image into a single dimension network, so a single dimension vector. And then you will have like so the traditional classifier network actually. So with the hidden layers, and then finally output layer. So typically, if you look into the any CNN, this is the architecture. So you will have an input. You will have like so the convolution layer. Each convolution layer can have multiple filters, followed by a pooling layer. Then, so second convolution layer, again it can have like some more number of filters, followed by pooling layer, etc. and so forth. Once the convolution operation is done, completed, you will have something called flattening layer. So basically, flattening layer is nothing but like so it will convert all the output of the last convolution layer into a one-dimension vector. So now it is a single one-dimension vector. So then you will have like so one hidden layer as part of the classifier, and then final classification layer. This is the architecture of SCN. Now, what is this filter actually doing? So typically, how do you define a filter? What is a filter? This is what the computer. So in your home also you use the filters, right? You have a
Depending
different
on
type
the,
of filter. Huh?
in order to understand certain things, what we need, we use this filters.
So basically, like okay, so if you are using a coffee filter, what is the purpose? You want only the decoction, but not the dust of the coffee, right? So similarly, so these filters, when I try to perform the convolution operation, image has lot of information. Each filter will try to pass only certain type of information. If I am using a high pass filter, it gives only the edge information. If I am using like so the kind of a corner filter, it will try to give only the corners. So similarly, like okay, so the purpose of applying these filters, multiple filters at this level is, see, I have an image has more contents, but filter bin will focus only on getting the edges. What are the edges present in the image? Filter 2 will try to get only the corners present in this image. Filter 3 will try to give only the a kind of a circular structure or like with the structure like this, a curve structure like this, etc. and so forth. Each filter will try to get certain kind of information. Now, when I go to the next layer, I don't see the original image. Rather than I get the composition of this kind of intermediate representation. So that means from a pixel representation, okay, this is your original image. Original image has got all the pixel information. this image was processed by a set of filter to get certain kind of information. And again, the next layer will try to further refine to get, so out of this all the edge information, it will try to extract only the meaningful information. The next layer will try to get much focused information, and eventually I am trying to extract only those information which are very, very essential to perform my task. What is my task? If my task is to recognize numerals, what is very, very relevant to recognize it as a numeral? Only that information I'm trying to get. Can you recollect now? So in case of a traditional machine learning, there is a gap between feature extraction and the classifier. Why? Because earlier only you decided like, so what features I am going to extract. But here, I am extracting only those features which are required for the classification purpose. I am trying to refine at every stage. So only the information which is very necessary for my classification task. All other information will be suppressed. Getting the point? So that is what the information it is trying to do. Like, so we call it as a feature pyramid. So that means from a higher information, like so the vast amount of information, I am trying to narrowing down at every layer. Every layer I'm trying to narrowing down to the information which is very essential for performing the classification. This is the last layer where I got some information. Now this information only I am trying to passing it to the classifier, and classifier will try to see whether it is classifying the numerals properly. If not, then it will adjust all these weights. Not only these weights, it will also go back and clean the filter information so that filter can focusly filter the data which is necessary for this final task. That way, effectively, we are bridging the gap between the classifier and feature extraction. Clear? Madam, did you understand like so how the what will be the structure of a CNN?
Yes, yes, sir. Thank you, sir. Thank you.
Okay.
So this is
All right.
being used for deep learning. CNN is being used for deep learning.
CNN is basically used for your signal processing. Like so, it could be like image, video, or even the speech signal. Like so, speech signal. In case of speech signal, we use one-dimension filters. So CNNs are very, very effective for handling image data, video data, or even the speech signal data, which can vary across. Okay, if your data is a tabular which is already fixed, right? So probably you can still use the CNN, but probably CNN may not be required because convolution operation requires a lot of operation, right? You can straight away use the deep network. If you are working with a tabular data, so a textual or the numeral data, you can straight away apply the concept of more number of layers, and you can perform the traditional neural network with more number of layers. CNN especially you try to use when your input is image, video, or the signal data, speech signal data. Speech, or it could be speech, or it could be any sensor data.
This is used in traditional algorithms, sir. It is in a traditional algorithm, machine learning algorithm.
So traditional algorithm also you can use. So you can use like instead of you manually extracting the features, right? You can use the CNN as a feature extractor. The last layer data, you can use it and you can give it to your traditional algorithm, like it would be on SVM or even like decision tree or random forest. Those kind of traditional classifier also you can use, not a neural network. So all you need to do is the last layer input, you can try to take it as a feature extraction and then you can give it to your traditional classifiers. That's still possible. That's what I mentioned it as a, you can use it as like feature extractor. Okay, the meaning of like so feature extractor is you can use CNN as a feature extractor and then you can use it for any classifier, traditional classifier.
Thank you, sir. Thank you.
Clear? Okay. All right. So let me quickly touch upon like some of the recent trends in deep learning. Just to give like so the glimpse about the kind of problems different industries are
Actually,
trying
sir,
to. Yeah. Yes. Yes, sir.
the transfer learning,
Hmm.
mainly we are focusing only centralized data now.
Come again. The last part I didn't understand.
The
So
transfer
transfer learning is
learning
used.
typically uses only centralized data.
Centralized. You mean centralized data?
Yeah.
Not necessarily. Like typically, the centralized data are like so the incoming data depends on like so, where the model is hosted. So if your model is hosted on a cloud kind of environment, it need not be a centralized data. Like so, the data can come from the multiple sources. See, transfer learning means basically what I mean is like, for example, your problem was to recognize the face recognition, like so detecting the faces,
Okay.
right? So this is your problem. You built a
Yes.
network. So this network has got like so the some of the communication layer, like so you train and you have the way you the finalized weight you have used it as a the model for face recognition, right?
Yes, sir.
Now I want to not only recognizing the face, I also want to add, let us say, like the flowers also. Face, and also I want to recognize the flowers.
Okay.
Right? So now the problem is, earlier your problem was to recognize only the faces. Now, along with the faces, I also want to recognize what kind of flower it is. I'm just taking a hypothetical. It may not be meaningful example, but just for a simplicity, I'm trying to consider. Now the problem is recognizing the faces as well as the flowers. This is the problem. If you
Okay.
are working on a traditional machine learning algorithm, probably you cannot combine these. You need to have a one classifier for this, one classifier for this, and then probably at the score level you can combine them. That is the only way of combining it actually. On the other hand, in case of a deep learning or the CNN, what you can do is you can already you trained for the faces. You need not to worry about this. Now you got the new problem, right? You can take the same layer, same network, start training on the flower images just by increasing the number of classes in the output layer.
Okay. Okay.
So some classes for face and some other classes, the newly added classes for the flowers. So
Flowers.
then still it will works. You need
Okay.
not to redo from the entire thing from the scratch. You need not to again retrain the cases for the faces. It's already trained. You can just add the classes corresponding to the flower and you can do the transfer learning. Transfer learning means I transferred the learning of already learned faces to recognize not only face, also the flowers. I'm transferring the learning, already
Okay.
pre-trained learning for another new class of problem to solve it actually. That's what the meaning of transfer learning. That means to address or to add the new number of classes, new classes, you need not to do the training from the scratch. You can already you
Fine.
can start from the state where it has already been trained,
Yes, sir.
and you can consider only the classes for new classes that has been added. Still, it
Okay,
will
sir.
work. Yeah.
Thank you, sir.
One deep learning algorithm, sir, because you said that in deep learning algorithm, both the classification and the user extraction will be done by itself. Can you
Right.
explain one deep learning algorithm with all the research?
Okay. See, for example, like let's say like your problem is to recognize the numerals. Okay. So I have a numeral image where I have written 0. So now you will have a CNN layers, initial CNN layers, which extract the features. This you understood, right? CNN layer.
Yes, sir. Yes, sir.
So
CNN, now understood.
after CNN, you will have like so the final
Yeah,
layer
one,
with
a
some
single vector, which will, it has to be
single
classified.
single dimension data. You got it actually. So now you got the single dimension data. So now this part corresponds to your feature extraction. Until this, what is the activity you did? You didn't do any classification. You just try to extract the features. Now, I try to flatten this last layer data, and I'm trying to use the traditional neural network. I'm just attaching a neural network. So traditional neural network, what it does, it has an input layer. Then you will have like, okay, so some hidden layer. And then like, okay, so followed by output layer. So, okay. In this case, output layer will be 10 because I'm trying to recognize the numerals. So now whatever the single dimension data I got it, right? I will try to give it as an input. And this will go to the hidden layer and it will try to train the output layer. If the output is proper, then nothing will happen. It will try to take the next data. If the output is not proper, then it will compute the error between the expected output and the desired output. And this error will propagate back to adjust the weights in all these layers. Got it? So this is how like the end-to-end system in the case of the CNN works actually. So in the case of a deep learning, so this part corresponding to feature extraction. This part is nothing but your traditional classifier itself, classification. Now these two are integrated. Not only integrated, even the training feedback learning will also percolate till this layer. So hence the gap between the feature extraction and the classification is reduced. Got it? All right. So, okay, we are running short of time. So yeah. So some of the trends where actively we are using the deep learning is especially in Samsung. So as a semiconductor and component manufacturing, we extensively use the deep learning technique to in our automation industry. So for the mainly for the purpose of defect classification, because whenever we try to manufacture the product, we need to segregate like so the defective product from a non-defective product. So the main purpose is if there is a defect at any stage, we want to segregate it so that it doesn't go for the subsequent layers of subsequent stages of the manufacturing. So early classification, early detection of these defects is what is very, very important. So that these are segregated from the process of further manufacturing. And at the same time, we can ensure the highest quality to the customer. Okay, so especially we are using the deep learning for the classification of defects and non-defect data. Okay, also we are using the deep learning techniques for anomaly detection. Anomaly detection means, see, in the manufacturing, there are many stages of the manufacturing. So a lot of sensors are attached to the each station. Like, so for example, this is a stage one of uh, plating. In case of a PCB manufacturing, this is a copper plating process. And then like, so we will have a etching process. And then like, so we are having a integration stages, finalization. So each of these stages, so there are a lot of sensors attached actually. Like, so even if you look into the copper plating process, right? So there will be like the plating, the copper density, and like so the time. So for it to measure and the temperature, to measure all these parameters, we have a lot of sensors. So at any point of time, if this stage is performing something wrong, so we try to get the sensor data and we analyze the sensor data using the deep learning technique to see is there is any abnormal behavior in the sensor pattern. If there is an abnormal behavior in the sensor pattern, we'll try to raise the alarm. At the same time, we'll try to see like so is there any what is the problem and try to adjust the uh, parameters here so that it can perform properly. Okay, the manufacturing can happen properly. That is another use case. And another case, like so what we are using the deep learning is for the recipe setting. In any manufacturing, so recipe setting is like just like in the cooking also, right? You have a different recipe. So, uh, for example, like so to prepare a what would I say? Uh, aloo paratha and chapati, roti and sabji, right? So the ingredients may be almost similar, but the recipe and constituents could be different because of that. Like so, your end products will be different. In a similar way, so every machines we have a multiple machines. So I can automatically set the parameters, set the recipe to ensure that the final product will be like, so what quality. I can control the quality and the type of output. Okay, so to do that, we try to predict the recipes, optimal set of recipe for product manufacturing. So these are the some of the cases like where we are actively using the deep learning, especially from the manufacturing industry. So not only like Samsung, even like say any industries which are involved in like manufacturing, definitely they will be using or they can use the deep learning technique for classification of defects and non-defect, and even the abnormal reflection, etc. and so forth. And again, like so somebody was mentioning about the speech recognition, right? So even deep learning can be used for the speech recognition. Your Siri, Bixby, Alexa, all works on the deep learning technique. Right? So they are trained and constantly being trained, upgraded based on the signals using this kind of data. Okay, so one good example could be like so the transfer learning is the basic model has already been trained. So now typically like so even your voice command, so when you are trying to train your voice, right, you will try to give like so very minimal sample. So based on that, it is able to recognize okay your voices, right? So that is a good example of a transfer learning. So where so the basic vocabulary has already been trained. Only thing is your voice pattern will be reinforced with a few number of samples. So that is a good example of transfer learning as well as the deep learning. So most of your voice assistant, right, Google Assistant or Siri, Bixby, Alexa, they are also like so good use cases of deep learning. And again like probably recommendation system. So most of you use the uh, retail websites to make a purchase, right? So the moment you try to purchase an item from Amazon, the next thing is Amazon will start recommending. Okay, so you purchase this item. Probably these are all the also the items probably you may be interested. So try to consider buying. So recommendation system like so recommending what kind of items, what kind of item may be an interest for you is also like with the possibility of deep learning. See, the recommendation system evaluation is slightly different. I can recommend anything. So I would say recommendation system is successful only when I recommended something and eventually my recommendation, whatever I recommended, is converted as a like the user acceptance. That means in this case, in case of Amazon or Flipkart, so if user end up buying that recommendation, then recommendation system goal is achieved. Okay, so this is a good example for both reinforcement learning as well as like so the deep learning concept. Okay, and another interesting application could be like the summarization. Okay, I have a huge document. I want to summarize. So again, like so, this is the very classical case of a deep learning. And similarly, like I have a movie clip or like so the 50 overs cricket match. I want to summarize it as a highlights. Okay, so this is again done with the help of a deep learning, especially convolution network in case of a video and image data, and traditional like the deep learning approach for case of the document summarization. And again, like in case of a marketing and sales, so to predict and coming up with the marketing strategy, so we are using a deep learning technique to assimilate the data coming from multiple source, multiple entities, to combine them to come up with a effective marketing strategy to increase the overall sales and the revenue. So similarly, like language processing, so uses a deep learning technique. Right? So nowadays, like so, the conversational AI is becoming more appropriate. I think you probably now whenever you try to interact, the first source of customer support will always be through the chatbots or the conversational AI. So that is again built on top of the deep learning techniques, right? And again, like so, especially for the case of traffic or the autonomous driving, or like pedestrian detection and vehicle detection. So the deep learning is effectively used. Even in case of the safety and security monitoring in the critical environment like airport, like so the large infrastructure. So we can effectively utilize the deep learning technique for recognizing the person, activities of person, or like baggage left over, like visit the airport. If some baggage is left unattended, so those kind of events can be effectively recognized using the deep learning technique. Even in the case of a precision farming, okay, farming and agriculture sector. So these days, like so, the deep learning techniques are effectively used. So this is where like so when you try to deploy these kind of solution, so again you need to always consider about the optimization of these models. Okay, how best I can optimize the model by controlling the trainable parameters so that I can effectively put those algorithms onto its devices. Okay, so even in this case of drone, okay, where like so the most of your analytics will put into the small onboard computer, so which can effectively control, right? So these are the some of the areas where I just wanted to touch upon. So again, this list is not exhaustive. I just collected few sample examples from different domains to showcase what are the different kind of use cases the different industries and research institute are trying to utilize or leverage the deep learning technique, both from the point of building and optimizing it for the real-time usage. Okay. I think uh, so. We are almost crossing the time. I think at this point of time, let me stop. So if you have any questions, if you need any use case, any input, let me know so that we can discuss and finally we can conclude.
In between, you try to, in order to classify a flowers in Google, you can expect what is that, sir? Is it an application or what is that? You said that you went and typed those things in order to classify a flower.
Yeah.
What is that one?
See, basically, like this is a kind of a framework, a Firebase Studio, so which can build the application based on the prompt. That means earlier, so to build a application, right? You used to give the company like if the application is small, you used to go for a small companies to build that kind of application. And if the application is very big, like you used to take the help of big software development companies to develop the software. See now, whatever the use case I have considered, it's not very simple case. It's a moderate kind of case. In spite of that, like so, the amount of effort I spent, I didn't even write a single line of code. Yet I was able to build the application. Okay, so I just wanted to show like okay, so what are the kind of the current development activities is in the area of the deep learning and the AI technique to generate this kind of code, right? So that's what I was trying to showcase. So you can, that means if at all you want to build any application, see for example, if you have any some problem like you want to solve, you want to build application, you can just build the entire end-to-end application using just a prompt, even without writing a single line of code. Okay, so that way earlier, like so, if at all you want to build any application, you need to know have the coding knowledge, architecture knowledge, tool selection knowledge. So now those things can easily be done with the help of simple prompts. Okay, so that's just I wanted to give the example. I don't know, there is some problem. I think it's not working. But you can try out actually. Like okay, you can just get into the Firebase Studio. You just give the prompt. It will be able to uh, uh, build a complete end-to-end application. And this application you can host. Okay. See, for example, you want to you have a CCTV cameras or the cameras installed in your classroom. You want to automate the process of taking the attendance. You can just ask a setup prompt and it can build an application, and that application can be used in your classroom to take automatically take the attendance without even calling the name of a student, right? So you need not to derive anything, but just basically to showcase like so the power of the recent. So where are the advancement? Like just wanted to show you the advancement of AI in the area of various fields. Okay, so especially in the field of software development, I just wanted to show you that.
This is free and anybody can use this one, sir.
Yeah, it's free. You can just type Firebase in your okay. Now I understand. Like I think probably the use you can just open Google and then like okay, so you use a type Firebase Studio. It will ask for you to create a login, and once that is done, I think probably you can start using it. Actually, see this is another application I built. So what I wanted to build is like so the classification of performing a different image processing operation. Okay, so I give a image and I want to do some kind of image enhancement. Okay, so that was the application. I think probably like web application to load the image and various sources, and it should be able to apply the various image processing operation on the image and show the result in the another video. Okay, so basically that was the application. That was the prompt. So it is. Let me play the image. Mm, let's see. So I made a mistake. I selected a little bigger image. I think it is taking too much of time. See, see the don't worry about like what application I'm doing. Basically, like the point is you can also start building this kind of application using this kind of. See, this is not the only tool. There are many such kind of tools available. So this is one Google tool like with the Firebase Studio. So similarly, like there are many such kind of systems which can be used to build the application from the scratch without even writing a single line of code, only through the prompts.
Sir, can you tell me those other similar tools, names?
So you have a client, you have a Code Llama from Meta. Okay, so these are all the tools which can generate the code based on the prompt.
Sir,
GPT
this
OSS, Code Llama, Client. So any other question? I think probably it's taking too much of time to load.
Sir, this Firebase Studio. I mean, in this Firebase Studio, can we publish the created app, sir?
Yes, you can do that. You can publish it. If you have your own hosted website, you can give the touch points. It can host there. Or even if you are having like so the open source, the cloud environment setup, right? You can even ask it to host it in AWS or like so those kind of framework.
Actually, I was tried, sir. It is asking account details, payment details.
Yeah, so you need to give the account details, right? Because if you are using a public cloud, you should have account details for that to host the solution.
It is asking payment, sir. Payment.
Okay.
Yes, sir.
Payment is not for this one. Like payment is for creating that hosting application. Like so, you need to pay that domain and like so for the web page hosting, right? You need to pay the charges, not for the application building. Mainly for
Yes,
like so the creating that domain, hosting domain. It is asking for the payment.
Yes, sir. Yes.
If you already have like so the Google account, you can use like Google or the Google Cloud or the AWS Cloud account. You can use that, utilize that, and you can map it. Actually, it will try to.
How to link, sir? How to link? It is directly go to Google Cloud. How to link the other
Here
clouds?
only you can just in the next prompt. I have this Google account. These are my credentials. Can you host this application in AWS? It will try to host it. Actually. You need not to do anything. Actually, you need not to do anything. You just ask like in a plain English text. You provide the prompt. It will try to get it there.
Okay, sir. Thank you, sir. Actually, I was tried, sir. It was worked, sir. I was in place of flowers. I was added
In my
animal.
case, like I recently changed the login setting. That's the reason it is not working. So
In
anyway,
place of flower, I was added the animals. I was uploaded the animal. It is showing exact details, sir. It's worked very well. Thank you so much, sir.
Okay.
Excellent session, sir. Wonderful.
Okay. Thank you.
Thank you so much.
Thank you very much. Okay. So if any other questions, we can discuss. Or if no questions, I think probably I would like to wind up. So just to conclude, like so we started with the concept of AI, and we understood like so what is the difference between traditional algorithm and the intelligent algorithm, and what are the different levels of artificial intelligence and different type of learning. And then we talked about what are the challenges with the traditional machine learning algorithm, and then how we considered about deep learning and what are the aspects of the deep learning and optimization aspects we need to consider. Of course, like so whatever the optimization is convert like I covered is very very limited, but there are like a whole lot of other things can also be done, like so from the architecture based different type of optimizations are available. If there is a possibility to interact in future, we will try to see. But nevertheless, don't only feel that okay, so whatever the optimization we learned today is the only these are the elementary things, elementary optimization technique where we can control the trainable parameters. And then like so we looked at few cases of how to build the convolution neural network and the convolution example, and then some of the trends in the area of different domains. So which are deep learning is being used in various domains and sectors. Yeah, I think that's what we covered. So thanks for wonderful interaction. I enjoyed the session. So if you need any further details, so regarding any of the topic, you can always reach out to me on my email ID, which I showed in the beginning. So I would be happy to share any whatever the details I can provide.
Sir, if possible, please share the PPT, sir.
I will share it through the organizers.
Thank you, sir.
Please share the mail, sir. Email ID, sir. Actually, I have a doubt, but I will contact through mail because due to time limitation, we cannot have. Please sir, share the email ID.
Yeah, this is okay.
Thank you, sir. Got it, sir.
Yeah. This is my email ID.
Okay,
So thank you, sir. Very nice presentation, sir.
Okay, thank you very much. Thank you all. And yeah,
Thank you,
I
sir.
take this opportunity to thank the organizers for giving the opportunity. Thank you all for wonderful interaction. And I'm sorry I overshooted that time. So I hope you will have like go and have nice dinner and good night. Thank you. Thank you.
Thank you, sir. Entire
Thank you, sir. Thank you very much.
Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir. Thank you
Thanks
so
to all the
much.
participants. So for today, it's over. Again, tomorrow we'll meet at 6 o'clock.